This is The Emergence of a New Ecosystem by Aryak Rashahi, Prabhat Ratan, and Akshay Pagade. Our location is Mexico City. Its current biome is a tropical deciduous forest. This is shown by the vegetation in the area as seen on the map in slide 2. The map shows tropical vegetation with some arid vegetation. The latitude and longitudinal coordinates for Mexico City are 19.4 degrees north and 99.1 degrees west. Mexico City experiences northeasterly trade winds. These trade winds blow in east-west direction, bring moisture from the ocean, and are cooling winds. A wet air mass presides over Mexico City. This is because of global pattern of air circulation and precipitation. High temperatures in the tropics evaporate water from Earth's surface and cause humid and warm air masses to rise and then flow towards the poles. These air masses expand and cool and cause precipitate to fall down. This precipitation is abundant in the tropical regions, which Mexico City falls under. Additionally, Mexico City experiences a sea breeze. This is because of its latitudinal position, which is at 19 degrees north, which falls in the 0 to 30 degrees range where sea breezes are present. Additionally, when the land heats up in temperature, a cool sea breeze blows in. Mexico City falls under no rain shadow effect because there is no mountain surrounding the city or near the city. In the rain shadow effect, if there is a mountain, on the windward side of the mountain, precipitate will fall and you will experience a growth in vegetation, whereas on the leeward side, the clouds are dry and descend and it's more desert-like. But Mexico City does not fall under these conditions. Mexico City has some seasonal variations with a warm season from March to June, while the cool season is from November to February. High levels of precipitation from June to September, up to 7.75 inches per month. Moderate levels in May and October, and little precipitation during the dry season, November to April, with less than 0.5 inches. This is because the sea breeze picks up more dense water in the summer months that condenses over Mexico City, while in the winter months, there is not enough energy to evaporate as much water. The bodies of water near Mexico City are the Gulf of Mexico and the Pacific Ocean. Biotic factors in Mexico City include the producers, which are cacti, agave, brittlebrush, ephedras, the false mesquite, pineapple plants, and ocotillos. Additionally, there is the ceiba tree. Consumers include humans, rattlesnakes, rabbits, the Mexican wolf, rock squirrel, prairie dog, hummingbird, mountain horned lizard, and white-tailed deer. Detrivores include bacteria and protozoa.
Another key detrivore is the Mexican golden eagle.
The carbon cycle occurs normally in Mexico City. Carbon dioxide is absorbed from the air by plants, which then release oxygen, and then animals take in this oxygen and through respiration release carbon dioxide back into the environment. Additionally, decaying organisms release carbon into the soil. Over thousands of years, these decaying organisms can turn into fossil fuels, and when burned, these fossil fuels release carbon back into the environment. This cycle repeats itself over time. The nitrogen cycle also occurs in Mexico City. Atmospheric nitrogen is fixated by bacteria in the soil and turns into ammonium through ammonification. Next, it is nitrified once again and turned into NO2 by the bacteria. Then it is nitrified again by bacteria and turned into nitrates, which is usable by plants in the terrestrial food web. The organisms consume the producers and eventually they die and they decay or they excrete, and nitrogenous wastes are released in the soil, which once again goes through ammonification, then nitrification, and then turns back into nitrites. Or once it has been made into a nitrate, it can go through denitrification by bacteria and is released back into the atmosphere. Additionally, through human impact, fertilizers can cause runoff into the local streams, but this is not a major focus of this project. Next, the water cycle occurs as expected in Mexico City. Water evaporates from the leaves of plants, from other ground areas, and lakes. The air rises, water vapor condenses and forms into tiny droplets, forming clouds. These clouds cool, and once many droplets are formed, precipitation will fall over Mexico City. This precipitation falls to the ground where plants will absorb the liquid from the soil, or it will be stored as groundwater. Fresh water will be put in the lakes. Additionally, there will be some surface runoff as Mexico City is urbanized. The water cycle is more active from the May to October months, which are the rainy season, and less active from November to April, where there is not as much rain.
250 million years later, Mexico City's ecosystem will experience a drastic change from where it is now. Its new latitude and longitude will be 2.173 degrees south and 46 degrees west. Mexico City will experience slight trade winds in an east to west direction, but due to the proximity of Mexico City to the equator, these trade winds will not have the chance to carry moisture and change the climate significantly. Mexico City will also experience a dry air mass as air masses from the Indian Ocean come into contact with a new mountain range, creating a rain shadow in which Mexico City is situated. This mountain range will prevent much of the precipitation from reaching Mexico City, maintaining the semi-arid climate. Sea breezes that originate from the Indian Ocean will carry moisture over the continent, precipitating much of it away before they reach Mexico City, leading to the city experiencing arid land breezes. The new mountain range to the east of Mexico City will prevent much of the moisture-carrying air masses from reaching the city, as they cannot cross the top of the range and instead leave a shadow-like effect of arid air on the leeward side, hence the rain shadow. As for seasonal variations, there is very little as Mexico City is now situated close to the equator where it receives an equal amount of sunlight all year long. Summer lasts from December to February while winter spans June to August. There is relatively little precipitation year-round, with the summer months raining slightly more than winter months. Temperatures remain stable throughout the year, with the winter possessing slightly lower temperatures. The temperature becomes hotter than before, with an average high of 87 degrees Fahrenheit and an average low of 70 degrees Fahrenheit, caused by the hot land breeze affecting Mexico City, which lies at a high altitude of approximately 8,850 feet due to the new mountain range. As for bodies of water, there's a small sea to the northeast of Mexico City, which is what remains of the Gulf of Mexico. The surrounding area may differ in the microclimate, as the Gulf of Mexico allows for more grasslands and fertile soil, slightly changing the local ecosystem. The major body of water is the Pacific Ocean to the west, absorbing some of the heat in the surrounding area and providing milder temperatures along the coast as the ocean's currents move south.
Over the many years of ecological evolution that have occurred in our environment of Mexico City, evolution has also occurred in our plant and animal species within our biome. This can be represented by our extant species and our extinct species. Natural selection has occurred, and many of the deciduous trees, such as the mahogany tree and the zapote, have become extinct because there is no more precipitation, and the precipitation that does occur isn't vital enough to support these trees. Another key species that has been extinct are the various deciduous lizards that lived within our previous population. And this is because these type of lizards aren't desert lizards and mountainous lizards that are more adapted to desert and mountain environments, which tend to have much less precipitation and much hotter, drier climates. These lizards rely on the precipitation and humidity of the deciduous forest in order to create saliva and mucus to help them survive. The extant species are very well adapted at this point through many generations of ecological adaptations and natural selection to the environment. Such species include the Mexican wolf, the cactus, in particular the pickle pear cactus, and also the Mexican rabbit. Many immigrations and emigrations have also occurred. The various immigrations include buffalo grass, the kangaroo rat, and leopards, whereas various emigrations include the hummingbird and the white-tailed deer, which will have migrated to the north, where there are more moderate climates with a greater access to water. Also, the Mexican wolf will migrate because there is a greater competitive advantage for its food source, the rabbits and prairie dogs, because another new immigration known as the caracal, which is one of the tertiary predators in the ecosystem. Within our biome, the food web is an extremely important part of how each organism survives. The primary consumers include the Mexican sunflower, cactuses, and also buffalo grass, which are eaten by the secondary consumers, mainly squirrels and rabbits and other burrowing animals. And then the tertiary consumers and quaternary consumers, such as leopards and the apex predator known as the caracal, which is actually one of the invasive species that comes into the ecosystem via immigration. It also contains a detrivore known as the Mexican eagle, the Mexican golden eagle, and this scavenges all the remains and decomposes the remains of various consumers and producers as well. The K species, which is the apex predator known as the caracal, supports the type 1 survivorship curve, where it has very few offspring. However, the offspring are extremely high quality and they typically live to an extremely long age. Also, this species exhibits a lot logistical growth perspective because of the carrying capacity and the various different competitive advantages and competitive disadvantages it has with other predators around it. It can't expand too much or else it'll eat all the secondary consumers. However, it can still maintain a high population because of the carrying capacity. The R species are kangaroo rats and Mexican buffalo grass, which are both invasive species. These tend to exhibit the type 3 survivorship curve, where they have a lot of different offspring, and these offspring tend to live very short lives because many of them are of very low quality. However, a few tend to live until older age where they can reproduce and continue to grow the population. The kangaroo rat and buffalo grass can both reproduce extremely quickly. Therefore, they will demonstrate an exponential growth because since they are also invasive species, they are not applicable to the existing carrying capacity for the other species, meaning they can use as many resources as they want without as much of a competitive advantage because they occupy their own niche in the ecosystem. The mountain squirrel is a prime example of speciation within our biome. This is because the mountain range that has just been created with the southern border of South America has separated the fundamental niche of the mountain squirrel, which used to be throughout Mexico City and South America. And now its realized niche has become the leeward side of the mountain range that receives descending dry air and is more arid and desert-like, whereas the other part of the species is on the windward side of the mountain that receives far more precipitation and has more fertile soil in order to produce a forest-type environment. This speciation is known as allopatric speciation because the geographical barrier is a mountain range. The mountain squirrels that live in Mexico City will evolve into a new species because over time they will develop such genetic variability through new adaptations and new evolutionary advantages such as bigger paws, bigger claws, and also many drought-resistant characteristics such as tougher skin in the mouth in order to eat more vegetation in the desert that are hard, such as cacti and rough grasses. And also, they will have to survive with less water, so they will adapt their bladder to become more water resistant. And also, this will create convergent and divergent evolution. So it'll create convergent evolution because since both animals are still in mountains, they will still have large paws and larger claws in order to help scale the mountains, but they will have divergent evolution because the other squirrel on the windward side of the mountain will not have to be as drought resistant. Therefore, it will develop various other advantageous traits in order to survive and best adapt to its new environment. Therefore, the genetic variability will be so great it will create new speciation between this previous species. The prickle pear flowering cactus is an extremely important keystone species within the biome of Mexico City. This is mainly because Mexico City is a vast desert, and within it, there are many populations and consumers, especially secondary and tertiary consumers, that need water for its survival. And they achieve this need and they fulfill their need for water by eating the prickly pear fruit of cacti, which have an extremely high water content because of all the water that can be stored within a cactus. They're also extremely high in nutrients such as nitrogen, and they use all the remaining nutrients they can accumulate throughout the ground and create through photosynthesis in order to create this fruit. Therefore, it is one of the most dense and rich nutrient sources within the entire ecosystem. Therefore, when animals eat this and they travel all along their desert, and as this fruit digests and excretes in their waste, the seeds actually burrow into the ground and help incorporate their waste and their fecal material, which is extremely nutrient rich and fertile, into the sand and soil. Therefore, this creates a more fertile land area, and over time, as weather patterns change and as more precipitation may occur over time, this can lead to extremely more fertile lands, which can allow for new growth of plants and which will allow the pre-existing population of the white-tailed deer and many other populations, it will allow them to immigrate back in to Mexico City, restoring its original biome. This is why the prickly pear cactus flowering plant is an extremely important keystone species within the biome of Mexico City. Thank you for listening to our presentation.